Good afternoon. We're the City of LA Plant Practicum team here to present our results for developing Ecotope-specific native plant lists and recommendations across Los Angeles' 16 ecological zones. Today, we'll walk through our findings. I'm Miranda.
I'm Alina.
I'm Juliana.
I'm Maddie.
And Suli.
And then I'm Kika. Our team also includes Zainab and Hayden, and our advisor, Dr. Travis Longcourt. Our client is the LA Department of Sanitation and Environment. So LA is a biodiversity hotspot with over 4,000 native species, but urbanization has fragmented the habitats here. Native plant biodiversity is key to resilient, low-input urban ecosystems, and LA's 16 ecotopes offer a framework for site-specific planting that restores ecological function. So what is an ecotope? We define it as a distinct geographic and ecological zone defined by its environmental conditions such as soil type, microclimate, plant species, and landforms. The city of LA is divided into 16 ecotopes, including riparian corridors, foothill scrub, and coastal terraces. So we made GIS integrated plant recommendations tailored to each ecotope based on historical flora, present-day conditions, and expert input. We're working to target the lack of accessible, ecologically appropriate native plant lists for the different environmental zones of the incredibly biodiverse city of LA. This knowledge gap has made it difficult for city landscapers and residents to plant a variety of native species appropriate to their specific area, which are crucial for biodiversity, water conservation, and climate resilience. So our question, how can LA residents, including planners, landscapers, and city staff, make ecologically smart planting choices rooted in the land's history and condition? Our goal, we also asked, can ecotope level plant lists help restore biodiversity and guide better landscaping? Our goal is to turn complex plant data into accessible recommendations. And by categorizing native plants into ecotopes for planting, we align with LA's biodiversity index and the Green New Deal. So for methodology, we research historical plant distributions from herbarium records. We assess current abiotic conditions, including like soil, sun, water. We also filtered for ecological role, drought tolerance, and plant survivability. We merged historical plant presence with modern environmental data to determine which native plants still make sense in each ecotope today. We started with large plant databases and then filtered using slope, soil, sun, and water needs. We use GIS data, ecological databases, historical sources, and real-world validation. Our 4 steps include ecological history research, key suitability factors, GIS analysis, and field validation.
Our ecology team has completed plant recommendations for all 16 ecotopes. There are 2 lists of native plants for each ecotope, one which encompasses all plants which have been found to be suitable to grow in the ecotope, and the other is a more refined selection of plants which represent the distinct character of each ecotope. So our cumulative list of native vegetation for each ecotope were created using a variety of sources, which record the location, necessary conditions, and distribution of native plant species. We used Cowscapes, Gypsum Herbarium, and other large registries of California native plants to cross-reference maps of plant ranges, primarily sourced from the Consortium of California Herbaria, with the map we have of the ecotopes in Los Angeles to accurately identify where plants will be suitable. Additionally, as the city has urbanized and environmental conditions have shifted due to urban heat island, soil grading, and water draining, different native plants can exist where they previously did not. So as such, using iNaturalist can record these shifts in plant ranges and suitability for our list as a final step. Within lists, we include pertinent information such as scientific and common names, plant form, soil, sun, and water needs, as well as elevation and slope ranges. For our list of standout ecotope-specific recommendations, we went a step further in our investigation by emphasizing the historical landscape and ecology of each ecotope and the ecological value that a plant could add to the region. For an ecotope composed of alluvial plain and California grasslands and meadows, we really emphasized grasses and herbs in our recommendations, as well as like riparian tree varieties characteristic of a floodplain, for example. Finally, in our report, Above our Ecotope standouts, we will acknowledge plants many Angelinos know and love, which can be found in the majority of ecotopes across Los Angeles and speak to the story of all of Los Angeles, but not just one specific area. These lists form the core scientific foundation of all of our deliverables.
So here are a few examples of recommendations for two specific ecotopes. The first one is Santa Monica Terrace, and a good tree for the Santa Monica Terrace is the Arroyo Willow, which is suitable for the elevation and the landform present. Another recommendation is purple needlegrass, which is California's state grass. Its deep roots are good for erosion control, making it suitable for this ecotope. And then lastly, a good shrub is the coffee berry, which is drought tolerant, pollinator friendly, and thrives in sandy, loamy soil, which is perfect for the nearby coastal conditions. Santa Monica.
A second ecotope we talk about is the Western San Gabriel ecotope. Some plant recommendations include the interior live oak, which is more suitable due to the high elevations of the San Gabriels, as well as the highly drained soil there. Long stem buckwheat is also another one that is very drought tolerant and is additionally fit for the nutrient poor soil of the mountains. And then finally, the very striking hallmark species of the woolly blue curls is fire adapted, well suited to hot, dry summers, and provides habitat to a wide variety of native California species.
So transitioning to our GIS work, our team created foundational map outlines by clipping regional ecotopes to Los Angeles' city boundary. We successfully integrated elevation and soil topography data from USGS and USDA sources. For soil type and sun and water availability, we leveraged our studio to clean and restructure complex data sets. By handling missing values, standardizing formats, and optimizing attribute tables, we created user-friendly ArcGIS Pro compatible layers. While our initial concept featured ecotope maps displaying basic environmental characteristics and plant recommendations, we evolved the project into a filterable interface. This enhanced tool will allow the city to input their specific location and site conditions to receive planting recommendations that ensure plant survival. To conduct our fieldwork, we have investigated sites across Los Angeles, including existing remnant habitat and urbanized or restored areas, to gather a large sample of plants present in either environment. Our visits to both remnant habitats and urbanized areas have yielded several key insights. First, we've confirmed that many historical plant associations remain viable in less disturbed areas. Second, we have created a visual library of native plants in natural and urban conditions across LA, which assists in validating some key recommendations. By cross-referencing with other native plant needs, we can see which other species tolerate those current urban soil conditions. These observations directly inform our suitability criteria and ensure recommendations work in real-world scenarios. To recap, our analysis produced 3 key deliverables to support sustainable landscaping across Los Angeles' 16 ecotopes. First, a comprehensive report detailing native plant recommendations. Second, a series of spreadsheets, one per ecotope, containing complete plant lists with site-specific data. Finally, an interactive GIS map with layered ecotope boundaries and environmental variables paired with a filter tool. Together, these tools transform complex ecological data into resources. These resources will be given to the city, who will use it to make informed decisions and ultimately integrate the approved findings into their public databases. The City of Los Angeles plans to use these recommendations to inform their planting decisions throughout our city in order to increase biodiversity and ensure that plants will survive for many years to come. And finally, I'd like to thank our advisor, Dr. Travis Longcore, for his expertise and general humor. I'd also like to thank an IOBS PhD candidate, Jared Kupfelt, for helping us develop our GIS work plan. Thank you so much.
Questions for the audience, but yeah.
Is there a way for homeowners or land managers to access this now, or do you think the city will make it available?
So as part of our project, this will be initially handed over to the City of Los Angeles, a Department of Sanitation, where they will do further refinements before they have told us they plan on integrating it into it's a unique part of Calscapes that's LA specific. So It won't be available now, but hopefully in the near future.
So, yeah,
Just curious, did fire risk at all come into your thinking, or, I mean, it's sort of a conflict between what we'd like to have out there and what is a fire promoting ecosystem, but did you think about that at all? Or take it into account?
So originally when we began our project, it was obviously at the forefront of our minds because it was in January. However, when we discussed it with our client, they decided that we should focus more on soil and water and sun availability, and they would further refine it later. So it was not part of our project as much.
And we'll do that.
nice work, guys. Well done.